Let's return back to the example in the textbook about trying to maximize the profit of electric can openers. And what I wanted to present you with is the possibility of there being more than one optimal solution. So in that example, we saw that one of those points, I believe was point A, was the maximum point of intersection with the isoprofit line with the feasible region. But what I wanted to mention is it is possible for your isoprofit line to have more than one intersection point with each of those corner points. And I just wanted to let's return back to the example from the textbook in 7.2 and adjust the numbers slightly so that it will illustrate the point I'm trying to get across. But let's say in exactly that problem, which just to refresh, was on page 299. It was the problem where we were producing electric can openers. Manual ones provided us with a profit of $4 per can opener, and electric were $6 per can opener. And we also had all of the constraints based on the production of those, where we had to use machines A, B, and C. And we had only a certain amount of time available to use those machines to make our can openers. And what we concluded is that the optimal solution was at point A due to the fact that the isoprofit line intersected there. Um, that was the biggest isoprofit line that could intersect with point A, and we used a graph to figure that out. And then we talked about why point A, another way we could figure that out is just by testing each of the corner points and seeing that point A, when plugged into the profit function, produced the largest profit of $520 as opposed to the rest, which produced less profit. But what I wanted to do in that problem is adjust the parameters. Basically, instead of using $4 for manual and $6 for electric, let's just assume we get the same profit from both manual and electric can openers. Let's just say $4 for the sake of argument. That's what it says here in the packet. So basically, that would adjust our profit function to look like this. P is equal to 4x plus 4y. Basically, $4 for manual can openers and $4 per electric can opener. And our goal of this would be to maximize our profit in producing the can openers under the same exact constraints as before. So what I wanted to show is, like, in this exact case, there's actually more than one possible outcome of the acceptable solution. So if we're looking at the same set of constraints, it's the same graph that we had on page 300, where our feasible region is here underneath all of the lines. But basically, if we graph that isoprofit region, notice that if we were to solve this line for y, and that's how you could kind of identify the isoprofit line, that would give us negative 4x plus p is equal to 4y. And if I divide by 4, I would get negative x plus p over 4 is equal to y. And this would be my isoprofit line, where I could just then choose P to determine, and where P represents my profit, and basically I could now randomly guess P and determine that. And that's kind of what I have here in the graph. So with my slider over here on the left, which you can't see, I can control the profits and play around with those isoprofit lines. But what I wanted you to notice about this particular case is that if I go over here to try to figure out what's the possible maximum point on the line which I can intersect, notice that it actually lines up with not just one point at the maximum point, because up here it doesn't intersect with the feasible region whatsoever. But at this point right here, it actually intersects with the feasible region at, well, 2 points, and actually more, technically, an infinite number of times, right? Because let's see if I can get this exactly on 600. Notice it intersects with both A and B, and actually technically every point in between. And this is an example of what we call multiple optimum solutions, because either A or B, and technically any point along that line, which intersects that previous line, which is x plus y is equal to 100, would all be perfect solutions. And again, the way we could do that is just by using our corner points and testing them. But basically what you'll see in such problems is if you ever see a repeated solution, It just sometimes there's more than one possible answer. So basically, I could test each of my corner points in this region on my new profit function, and we'll see is a repetition of those values. So, again, looking at those 5 corner points, those were these 5 points here: 40, 60, 80, 20, 90, 0, 0, 80, and 0, 0. We could test them in, like, mathematically speaking, we could test them into our new profit function, and we'll just see there's an overlap. So let's try each point individually. So let's start with, let me try to move this out of the way so that I can work on it at the same time. Okay, sorry, it's a little bit awkward to try to do. But, and I'll put this right here so we can see them both at the same time. But the profit for corner point A would be 4 times 40. So actually, let me be a little bit more clear about the work I'm doing here. So again, this was my profit function based on these new parameters that I just am imposing to make an example. And if we try, basically I'm going to try each point. Corner point A was 40, 60. I had corner point B, which is 80, 20. And actually, as we were looking at the isoprofit lines in GeoGebra, those were the two that both intersected the isoprofit line. The other one should be less, but let's just go ahead and test E and C for the sake of argument. And D is obviously not going to be a solution, so I'll just not bother with that. But point C was 90, 0, and point E was 0, 80. And I'm going to check each of those points in my profit function just to see what happens. So in my profit function, so 4 times the number of manual can openers plus $4 per electric can opener. So the profit of producing 40 and 60 would be 160 plus 240, which is, of course, $400 under these new parameters. So for doing 80 and 20, notice that would be 4 at 80 plus 4 at 20. That would give me $320 plus $80, which is also $400. But what I can see here is there's two different answers, multiple optimal solutions, both that kind of give me the best possible answer. And if I look at these other options, say for example 90 and 0, that would give me 4 times 90 plus obviously 4 times 0, which is $380. Notice that those other corner points are less, but basically I can have a situation where there's technically multiple different answers that work, and that's always going to happen if your isoprofit line has the same slope as your that would be 360 in this case, if it has the same slope as one of your constraints. So like going back, I can see here that this constraint equation had the same slope as the isoprofit line, aka the profit function, and that's what caused us to have multiple solutions, both A and B giving me the same profit of 600. And for some reason, I'm getting a different answer in my graph. Oh, you know what? I forgot to change one of the equations here. So this is actually wrong. But the idea is still sound. And just the numbers weren't matching up with what I'm doing over here. But obviously this is right based on the new parameters, which tells me that my optimal profit should be $400. And I should produce... Well, and then the question is, what's the right answer? Should I produce 40 manual and 60 electric, or 80 manual and 20 electric? Well, the kind of our conclusion here is it doesn't really matter, and we have multiple different solutions. So we could then look at other factors to try to decide. And actually, anything in between would also work. Like say, for example, 60, 40. Since those were all along that line, anything in between them on that same constraint line, which was x plus y equal 100, as long as you're on the constraint line, it will be another potential solution.